Hello friends, in this video let us discuss about the voltage regulation of transformers. So the voltage regulation can be defined as a percentage of the voltage difference between the no load voltage and the full load voltage to the reference voltage taken. So where E2 is the no load voltage and V2 is the full load voltage, and with respect to the reference voltage it may be either E2 or V2 depending on the equipment you are using in the power system. So this is what your voltage regulation means, that is the percentage of voltage difference between no load and full load with respect to its reference voltage is defined as the voltage regulation of transformer. So let us now consider a transformer with its secondary circuit open. So the secondary circuit open, it means that no load is connected to the secondary terminals. So when there is no load connected to the secondary terminals of a transformer, that means the secondary terminal voltage will be equal to the secondary induced EMF. Secondary induced EMF. So when the working is simple, when you apply a AC voltage source, the injection of AC current takes place. So there will be the alternating electromagnetic field which will be flowing through this core, and they will link with the secondary winding, and you will be having an induced EMF, and that induced EMF is indicated by E2. So when there is no load, the secondary terminal voltage will be equal to the secondary induced EMF E2. That means if I say secondary terminal voltage will be equal to E2. Now when a full load is connected, let me say when a full load is connected to the secondary open circuited terminals, then as we are connected a full load, it will draw a rated current. So the rated current I2 starts flowing in this secondary circuit. So this rated current also results with the voltage drop associated with the secondary circuit, and if I say Z2 is the secondary impedance of the transformer, then the voltage drop will be equal to I2 Z2. So at this condition your secondary terminal voltage will not be equal to this E2, because we have witnessed there is a drop in the secondary terminal circuit due to the current flowing in the secondary circuit as when the load is connected. So here your secondary terminal voltage, if I indicate it with V2, it will be equal to E2 minus I2 Z2. So your circuit will be, this is the secondary resistance, and here this is your load, this is E2 and this is V2, this is R2, this is X2. So this is basically how your circuit looks when you connect a load to the secondary circuit terminals. So here we have seen this is E2 minus I2 Z2. So now the expression for your voltage regulation can be given by two types. So the voltage regulation based on the reference voltage we are using, the regulation can be given in two forms. So one form is, let me say, that is a regulation down, and the other form is regulation up. So the regulation down is given by the percentage of voltage difference between the no load voltage and the load voltage upon the no load voltage. So here this no load voltage, if I say this is VNL over E2, which is no load voltage, is the one being given by the power supply provider, and the user has no control over this no load voltage, and hence this no load voltage is taken as a reference basically in transformers. So basically in transformers this no load voltage is taken as a reference, and which we are saying the term voltage regulation down, and the regulation up will be given by the expression E2 minus V2 by V2, because in alternators and power system this user end voltage is guaranteed by the power supply provider. So this will be taken as a reference voltage in the voltage regulation up. So basically in the transformer, these both definitions will result in almost more or similar values, as the transformer impedance is low and the power factor is quite high. Both the definitions can result in more or less the same value. So you need not worry which definition has to be applied, because they will almost result in the same value. Because of this reason, the impedance is low and the power factor is quite high. So now let us derive the voltage regulation of a transformer for a lagging power factor. So the term lagging power factor, it means your current is lagging to your voltage. Your current is lagging to your voltage. So let us draw the phasor for this. So if I say this is your V2 and your secondary current is lagging your secondary terminal voltage by an angle, let us say theta 2. So basically the lagging power factor, we are considering the secondary current I2 is lagging to the secondary terminal voltage V2. So again, now considering the drops, that is I2 R2 and I2 X2. So here this will be parallel to this secondary current. This is I2 and R2, and again I am having the reactance drop. This is I2 X2. So your secondary no load voltage or the secondary induced EMF will be the phasor sum of all these quantities. This is your E2. So now here let us perform some mathematical calculations. So let me extrapolate this to here, and let us indicate this is my point O and this is my point A, this is B and this is C, and let me give this is D, this is E and this is F. So this will be the same angle, that is the theta 2, and here again we are having an angle theta 2. So from this phasor diagram I can write, if I know here OA, AB and BC, so let me take OC here. So basically this angle will be your delta, that is the angle between the secondary induced EMF and the secondary terminal, the secondary full load voltage. So your OC will be equal to OA plus AB plus BC. So I know OA is equal to V2 and here AB. For this AB, I know if I apply cos theta 2, I'll get this AB. So your AB will be equal to, your AB will be equal to I2 R2 into cos theta 2 plus your BC, which is nothing but DE. BC is equal to DE. So your BC, again applying the sin theta 2, I'll get my DE or BC. So your BC will be equal to I2 X2 sin theta 2. So this is your OC, but in the transformer generally this angle between the E2 and V2 is very small. So we are considering this OF will be equal to OC. So this will be equal to OF, and which is nothing but E2. So your E2 will be equal to V2 plus I2 R2 cos theta 2 plus I2 X2 sin theta 2. So this is your E2. Now let us put this E2 in this regulation down formula. So from there I will get the regulation will be equal to, so basically V2 will get cancelled here, because V2 and we will get minus V2, so both will get cancelled, and I am left with the regulation I2 R2 cos theta 2 plus I2 X2 sin theta 2 upon E2 into 100, I'll get the percentage regulation term. So similarly, let us consider for the leading power factor, that means your I2 is leading your V2. That means the secondary current is leading the secondary terminal full load voltage. So if I draw the phasor, so let me draw the phasor. So this is your V2 secondary terminal voltage, and this will be your I2, and let us say the angle is some theta. Let us say the angle is theta 2 again, and your drop, this drop will be in phase with this. So this is your I2 R2, and perpendicular will be your I2 X2. So let me drop down this here, so and extend this here. So if the phasor sum will be equal to your E2. So this is your I2 X2, I2 R2, and this is your V2. So let me write the points. This is my O, this is C, this is A, and this is B, this is D, this is E, and this is F. So again, I know this OC value, I know this AB value, and I know this BC value. So what I do here is, I'll take OC, OC will be equal to, I will write OA, which is nothing but the V2 plus AB minus BC. This is what you get. Observe it carefully. We know OA, we know AB, and we know BC. So I am taking OC will be equal to OA plus AB minus BC. I hope we are doing right. So from here I will write OA will be equal to V2 plus your AB will be equal to, again this will be your theta 2, and this will be your theta 2. So I can write this I2 R2 cos theta 2 minus I2 X2 sin theta 2, because from here you can see BC is equal to ED, so I am taking I2 X2 sin theta 2. So this OC will be equal to this F, as the angle between them is very small, that is delta is very small. So I am writing this OC, which is equal to OF, OF equal to OC, and which is ultimately equal to, this will be equal to your E2. So let us put this E2 here. So after putting this E2 here, you will be having the regulation. The regulation will be I2 R2 cos theta 2 minus I2 X2 sin theta 2 upon E2 into 100. So this is the voltage regulation for a leading power factor. This is for a leading power factor, and this is for a lagging power factor. So the only difference we are noticing is, here you are having plus and here you are having minus. So now let us consider the condition for zero voltage regulation. So for the zero voltage regulation, basically what we have to do is that for the regulation to be 0, put this equal to 0. So the numerator has to be put to 0. So then if I put this to 0, the expression will be I2 R2 cos theta 2 plus I2 X2 sin theta 2 will be equal to 0. So by putting it to 0, I'll get my tan theta 2 will be equal to, so your tan theta 2 will be equal to minus R2 by X2. So here the minus sign indicates that the zero regulation takes place at a leading power factor. So the minus sign indicates that the zero regulation takes place at a leading power factor. Now let us find the condition for the maximum regulation. So for the maximum regulation, what we have to do is, we have to just put the d by d theta of the regulation to be 0. So if I differentiate this regulation with respect to theta 2, then I will get my maximum regulation condition. So if let us put this here, if you put d by d theta 2 here, so the expression we get is, I'll get minus I2 R2, this will be sine theta 2 upon E2 plus I2 X2, that will be cos theta 2 by E2 will be equal to 0. So this is the expression you will get. Now from here, the tan theta 2, your tan theta 2 will be equal to, this is your tan theta 2 will be equal to, so this, if I take this right side, so after taking this right side, I will be having here R2, so this comes sin theta cos theta, so this will be basically your X2 upon R2. So this is the expression you get after taking this term to the right side, and from here you can see there is a positive sign, and this positive sign indicates that the maximum voltage regulation takes place at a lagging power factor. So let us draw the percentage voltage regulation with respect to this power factor. So if I draw the percentage voltage regulation, so let me say this is my percentage voltage regulation, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this is my power factor 0.5, this is 0.5, and this is basically your leading, this is 0, and this is 0, here you are having the power factor 1, and this is your leading power factor, and this is basically your lagging power factor. So the plot will be like this. So the zero regulation is achieved in the leading power factor, and the maximum regulation will be achieved in the lagging power factor. So this is basically the plot between the percentage voltage regulation and the power factor. So in this way you are having a lagging power factor, and in this way you are having the leading power factor. So this is all about the voltage regulation of a transformer. I hope you understood well. Please subscribe to the channel. Thank you.